Well, hello. It's Monaco here. Shout out to my homie Milks. I'm about to start this unit on solutions. We're going to study what happens to water when you mix stuff into it. Okay. What is a solution, solute, solvent, and all the special properties that come about in this special type of matter that is a homogeneous solution. So let's check out our themes, targets, and assignments. There we go. We got our learning targets coming this way. What are we going to learn? And how are we going to learn it? There you go. Let's check it out. Clicky button, computer. So, essential questions. Why do some things dissolve in water while others do not? Okay, there's a special rule I'm going to teach you. It's called like dissolves like, and we'll see those details later on. Why do ionic compounds allow water to conduct electricity? You saw this in chemical bonding unit in that lab where you took the conductivity tester and some of the chemicals turned the light bulb on and allowed the water to conduct electricity. The question is why? Why does like dissolve like work as a rule? Okay, we're going to use some things we learned in chemical bonding. Polarity is the key here, and we're going to see what and why. How does temperature and solvent volume change solubility? We're going to use reference table G again to study solubility. Okay, how temperature changes that. How do you quantify, put a number on, solubility beyond diluted and concentrated? So we're going to measure solubility with units like molarity, percent by mass, percent by volume. Okay, we're going to put numbers on concentration. What happens to the properties of water when solutes are added? This is our famous ice cream lab unit. Okay, so let's get to it. Our learning targets. Got to be able to say I can. I got to be able to identify a solute and solvent in a homogeneous solution. Which one is which? What's the solute? What's the solvent? Got to know it. Next thing, use table F, which is a new reference table, to predict the solubility of compounds in water, if they will dissolve or if they will not dissolve. Tell me if a solute will dissolve, soluble, or soluble covalent, or dissociate, soluble ionic, when placed in water. Use the term like dissolves like to determine if two substances will mix. Why don't oil and water mix? We'll have to use the term like dissolves like as it pertains to polarity for the explanation. State relationships for the factors that affect solubility. So as temperature increases, the solubility does for this particular substance. Or as temperature decreases, the solubility does that for a different substance. Okay. Let's see, use table G to classify these solutions as saturated, unsaturated, or supersaturated. So graph reading skill, okay? Table G to find changes in amounts of solute in solution. Another graph reading skill from table G. As you change the temperature, how much amount of material can you change about being dissolved in there, more or less? Does some precipitate? Can we add more? Calculating concentration in molarity, parts per million, percent by volume. So straight up mathematic calculations using reference table T. Comparing concentrations, dilute versus concentrated. What is a dilute solution? What is a concentrated solution? Which one is more dilute? Which one is more concentrated? Using those quantified values of molarity and such. Predict how adding a solute to water will change its properties of boiling and freezing. So when you add stuff to water, the water doesn't boil and freeze at the same temperature anymore. Be able to predict how the stuff you're adding affects the temperatures of freezing and boiling for water. And here's your reference chart. Okay, so you got to do the unit. I suggest doing it in this order. Okay, very straightforward. Check it off as you go. And I think that's it. So I will see you guys and gals next video when I hit up all the vocabulary terms. Yes. Excellent. Now I shall click the button and turn off the video.